Hello, my name is Maxim Loika. I would like to present my research paper, Stirling Engine Model, which is dedicated to the conversion of thermal energy into electric current. The purpose is to create a working model of Stirling engine for evaluation its profitability. The tasks are to study the history of Stirling engine creation, its types and principles of action, to assemble a working model of the Stirling engine, to determine the profitability of the engine, to review possible ways of the engine's using, and to create a site. The Stirling engine is a thermal machine in which the working medium, in the form of gas or liquid, moves in a closed volume, a type of external combustion engine. It is based on the periodic heating and cooling of the working medium, with the extraction of energy from the resulting change in the volume of the working medium. It can work not only from fuel combustion, but from any source of heat. In our work, we decided to build a model of a gamma-type Stirling engine, which is a compromise between beta and alpha types. I have created 5 models. Experiment number 1. The profitability of the Stirling engine. To begin with, I found out how much my family pays for the electricity. We pay 8 rubles for 60 or 70 kilowatts of electricity. Next, I found an industrial Stirling engine. Its power ranges from 2 to 9 kilowatts. Therefore, to generate 60 kilowatts, it is necessary to provide 8 hours of engine operation. In this example, gas is used as a fuel resource. In 1 hour, 0.4 cubic meters will burn. It is about 15 kopecks. Therefore, for 8 hours of work, we will pay 1.2 rubles. Conclusion: engine is cost effective. Experiment number 2. Comparison of different fuel resources. On this slide, you can see that gas, alcohol, and coal are profitable, and gasoline is not profitable. We couldn't find the kerosene because of the missing data. Experiment number 3. Calculating the number of Stirling's engine turnovers. A tachometer was developed for calculating the number of turnovers. This tachometer was created on the basis of Arduino Uno board. This system is programmed in Arduino IDE environment. The code was written using C++ programming language. Experiment 4. Building graphs to show that efficiency depends on the temperature of the heater or cooler for Carnot cycle and Stirling cycle. For building the graphs, we used Microsoft Excel 2013. These calculations are available on our website Двигатель.fun in the About Research section. Experiment number 5. Efficiency of the cooling system. We conducted an experiment to determine the efficiency of the cooling system. Namely, we measured the temperature of the refrigerant in different periods of the engine work. Graph number 1. According to the data obtained, a smart cooling system was created. It consists of a temperature sensor, DS18B20, put in a refrigerant, a decoupled microcontroller for Arduino Uno, a low-level relay, power supply to the cooler, and a cooler for heat removal. The principle of operation is very simple. When the extreme temperature limit is reached, 60 degrees Celsius, the cooler fan is turned on to remove heat. Possible using. We assumed that if you embed a heating area in the heat circuit and a cooling system in the cold water circuit, the engine would be more profitable. So, temperatures in the pipeline will decrease, and cold water supply will increase, and electricity will be generated. Nuclear power plants areas. Any nuclear power plant has a cooling system. It is represented by a cooling tower or a reservoir. So, if we put some of Stirling's engines between the turbine and the cooling system, we could reduce the cooling system's load. And even without that, we could generate an electrical current. Woodworking areas. It is no secret that enterprises have wastes, nor are they exempt from wood processing. But unfortunately, not all the waste can be recycled. We offer this waste as fuel for the Stirling engine. Heat pumps. The subject of heat pumps is very popular. At the moment, the heat pump system is used to heat residential buildings. So our proposal is to transform heat pump system to Stirling's engine. The system consumes very little, but initial investments are costly. Conclusions. Having examined the structure and operating principle of Stirling engine, we created its working model. After some tests, we came up to a conclusion that Stirling engine is very profitable. It's 5 times more profitable than modern sources of electricity. So Stirling engine can definitely be used in various sources of electricity: pumps, submarines, solar stations. Thanks to its omnivority and simplicity of design, Stirling engine is eco-friendly and economical. So it also could be used in heat pumps, power and woodworking areas. For more information, please visit our website dvigatel.fun.